Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we'll be solving Mastery Exercise 3 from your Intro to Statistics class. So let's get started with the first problem. So here is our first problem. And here we are asked to find the 34th percentile from the following data. So the data set is given here, and you can see that the data is already arranged in ascending order. So what we do is we try to find the 34th percentile, which is also denoted as P34. 34th percentile is P34. In order to find the percentile value, first we need to locate where that value is. So what we do is, for the location, we have the formula. We have the formula I equal to K divided by 100 multiplied to N plus 1. So in this one, we are looking for 34th percentile. So the value of K will be 34. So this is 34 divided by 100 multiplied to N plus 1. N is the total number of observation here. So if we count 1, 2, 3, 4, 5, and let's see how many 5 are there. 1, 2, 3, 4, 5, 6, 7. So 5 times 7, 35 plus 1. So that is 35 plus 1, which is equal to 34 divided by 100, 0.34 times 35 plus 1 is 36. So the value of I, or the position of the 34th percentile, if we multiply these two, it is 12.24. That means the 34th percentile is after 12. Okay, 34th percentile is after 12th item. So if we get decimal, so like this one, 12.24, we have to find the average of 12th and 13th item. So what I mean by that is P34, or 34th percentile, is equal to 12th item, or 12th value, plus 13th value, and divide that by 2. So in this case, the 12th value, 5, this is 10, so 11, 12. 12th value is 26, plus the 13th value is 27, and we divide that by 2. 26 plus 27 divided by 2 is 26.5. So the 34th percentile, which is the average of these two numbers, 26 and 27, is equal to 26.5. So the 34th percentile is 26.5. Okay, let's move on. Here is the next example. Here we are asked to identify the 5 summary number. Okay, identify the 5 summary number. And these 5 summary number are minimum, first quartile, median, third quartile, and maximum for the data which is given here. When you look at this data carefully, you can see that this is already a well-arranged data. So we want the minimum value, the first quartile, median or second quartile, third quartile, and maximum. Because the data is already well arranged, it is easy for us to find the minimum and maximum value. In this case, as you can see, the minimum value is 3 and the maximum value is 95. Maximum value is 95. So for the problem like this, if it is well arranged, we can easily write the minimum and maximum value. And if the data size is small, we can actually do the math and find Q1, Q2 or median, and Q3. But here, I'm going to show you how we can use calculator to find these values. So here is my TI-84 calculator. First, we need to enter the data. So for that, we go to Stat, and under Edit, number 1, it's already highlighted. So we just press Enter. And over here, under List 1, we enter the data. Okay, we enter the given data over here. And then to find different values, we go to Stat again, and then we go to Calculate. We are looking for the values under one variable is Stat. One is already highlighted. So we enter. We have the data value in list 1. There is no frequency. So we calculate now. And you'll see the value. See, minimum value is 3. We have the first quartile, Q1, 32. And then there is a down arrow there. So if you press that down arrow a little bit, you will see that's a Q1. Now median is 59. Median is 59. And then the third quartile is 85. Third quartile is 85. And the maximum value is 95. We have seen the minimum and maximum value directly from the data. We get the other 3 numbers from the calculator. So these 5 numbers, minimum, Q1, median, Q3, and maximum, these are called the 5-number summary for a given data set. Okay, I have all those numbers written here. So that is the end of this problem where we're asked to identify the 5 summary number. Minimum, Q1, median, Q3, and maximum. Now let's move on to the next example. So here is next example. Based on the data below, identify the 5-number summary. So again, we are looking for those 5 values. That is, we are looking for the minimum, Q1, median, Q3, and then maximum. So let me quickly make this table so that we can write down these values here. Okay, now if you look at the data is not arranged. We have a 67, then we have a 57, then 53, 15. Data is not arranged. So we cannot directly say what is minimum or what is maximum. If you look at it carefully, then only you can see the minimum and maximum. So what I'm going to do is I'm also going to find these 5 numbers using calculator. So for that, in TI-84 calculator, I need to enter these numbers first. Here is my TI-84 calculator. So first we go to Stat, and then we select under Edit number 1. And under List 1, we enter the data. So once the data is entered, we go to Stat, and then to Calculate. And we are dealing with one variable Stat, so we select that. We have the data under List 1. There is no frequency. Now we go ahead and calculate that. So once we do that, we'll be able to see those 5 numbers here. You can see the minimum value is 13. Minimum is 13. First quartile is 36. Median is 55.5. 55.5 is the median. Third quartile is 72.5. 72.5 is the third quartile, and maximum is 100. So that's how you can use your TI-84 calculator to find those 5 numbers. So these are the 5 numbers that we got from the calculator: minimum 13, Q1 36, median 55.5, Q3 72.5, and maximum 100. So all we need to do here is plug in the numbers in TI-84 calculator and get this number using those using the TI-84 calculator. Example: find the mean, median, and sample standard deviation for the following data. So here we have the data value. So this is the individual data set without frequency. This is not grouped. And we are asked to find the mean, median, and the sample standard deviation. So we are looking for 3 things. The first is mean, second is median, and the third one is standard deviation. I'm going to show you how to do this one using TI-84 calculator. Here is my TI-84 calculator. So first we are going to enter the data, for which we go to stat and then under edit number 1, which is already selected. So we press enter and then we enter the data value here under L1. So once we enter the data, we go to stat again, and this time we go to calculate and we go to one variable stat, which is already selected. So we hit enter. Our data is under list 1. We don't have frequency, so we'll leave this blank. Now we'll press calculate to get those values. So once you do that, you can see that the mean, so that X bar is the mean. Mean is the X bar, so you can write it down. Mean is equal to 16. Next thing we want is median. Median is down here. Here is minimum Q1. So if you go a little bit down, you'll see median. So median is denoted by MED here. And you can see the value of the median is equal to 19.9. That is median. And then the sample standard deviation, you can see there are two standard deviation here. The one denoted by the Greek letter sigma is the population standard deviation, which is 10.4529. Whereas this one denoted by S is the sample standard deviation. So sample standard deviation is always denoted by S. And for this data, the value of the sample standard deviation from our TI-84 calculator is 11.0184. So using the TI-84 calculator, we got these three values: mean 16, median 19.9, and sample standard deviation 11.014. Let's look at one more example, which is quite similar to this one. Here we have calculate both sample and population standard deviation. So we are looking for sample and also population standard deviation. So as discussed in the previous problem, sample standard deviation will be denoted by S and population standard deviation will be denoted by the lowercase Greek letter sigma. And we are asked to show the following answer to one decimal place. And we are also solving this using calculator. So first we need to enter this data in our TI-84 calculator. So here is my TI-84 calculator. First we need to enter the data. We go to stat, under edit number 1. Now under the list 1, we are going to enter the data. Our data values are 10, 1, 8, 3, and then 5. So once you enter the data, we again go to stat, and this time we go to calculate, and we are looking for one variable stat. So that's number 1, which is already selected. So we press enter. Now our list or the data is under list 1. We don't have frequency. We'll leave that blank. Now we'll press calculate and we get the values. We were looking for the sample and the population standard deviation. As I told you before, sample standard deviation is denoted by S. So if you look at this screen, you can see the sample standard deviation is here. We are asked to write up to one decimal place. So if you round it to one decimal place, that will be 3.6. And similarly, the population standard deviation is denoted by sigma, the Greek letter sigma. And if you look at the screen here, the population standard deviation is this one. And when you round it to one decimal place here, after this number, we have a 6, which is more than 5. If we have this number 5 or more, we round up. So here we add 1. That means this will be 3.3. So the population standard deviation for this one is 3.3. So these are the values that we obtained from calculator. Sample standard deviation 3.6, population standard deviation 3.3. So you have seen that we can use our TI-84 calculator to solve problem like this one. So let's move on to next one, which is very similar to the previous two examples. So here is the one. The data is from a sample. Calculate the mean. So let's see what we are asked to find. Mean standard deviation, and variance. Okay, and clearly it is said the data is from sample. So that means these values are: mean is the sample mean, X bar, standard deviation is the sample standard deviation, S, and when we say variance, variance is the square of the standard deviation, so that is S squared. And here we are asked to give the answer to 2 decimal places. And again, we are using calculator to solve this. So I'm going to bring my TI-84 calculator and solve this one. So let's do it together. Here is my TI-84 calculator. So first we go to stat and under edit number 1. And under list 1, we'll enter the data. I've already entered the data here. Once you enter the data, we again go to stat. This time we go to calculate and we select one variable stat, which is already highlighted. So we just enter. We need to verify that the data is in list 1. That's right. We don't have frequency. So we go to calculate. And once you hit calculate, you'll see the values here. Mean is this one, 25.0375. We are asked to write up to 2 decimal places. So this will be 25.04. That will be your mean. 25.04 is the mean. Sample standard deviation denoted by S is here, which is this one. And when you want to write up to 2 decimal places, it will be 10.95. 10.95. And then the third one that is asked in the question is the variance, which is the square of the standard deviation. So it should be the square of 10.95. So let me go back to the main screen. We have 10.95. We square that because the square of the standard deviation is the variance. So when we square that, we get 119 point, when you want to go up to 2 decimal places, 90. So 119.90, that is the variance. So you can see we got mean equal to 25.04, sample standard deviation 10.95, and variance 119.90. We use calculator to solve this problem.
Okay, next example. This data is from a sample. That means the data given here is the sample data, because it said this is the data from the sample. We are asked to calculate the mean. That means we are looking for sample mean. Okay, mean. Then the standard deviation. So that's also the sample standard deviation. And the coefficient of variation. So because we are talking about the sample, or the sample data is given, we denote the mean by X bar, standard deviation by S, and the coefficient of standard deviation is the standard deviation. So here is the formula. Coefficient of variation is the standard deviation divided by mean multiplied to 100%. So if we use this formula, we get the coefficient of variation, because coefficient of variation is the ratio of standard deviation to mean expressed as percentage. Okay, and also in this problem, we are asked to solve using calculator. Use calculator to solve it. So I'm going to bring my TI-84 calculator on this screen and show you how we can do this. Okay, here's my TI-84 calculator. First, we go to stat and under edit number 1. And under list 1, we enter the data like this. And once the data is entered, we go to stat and then we go to calculate and we go under one variable stat. Then we verify under list 1, we have the data. We don't have frequency, we leave that blank. We go to calculate and hit enter to get the result. So here you can see mean is 31.29. So our sample mean X bar is 31.29. Sample standard deviation is here, which is 12.24. And the third one we are asked to find is the coefficient of variation. So let's go back to the main screen here. So coefficient of variation is the standard deviation, which is 12.24. We divide that by mean, which is 31.29. And that result is 0.39, and we multiply that by 100. It's 0.39 and some numbers after that, because it is fixed to 2 decimal places. So when you multiply, in fact, it is 0.3912. So when you multiply by 100, we get 39.12. So the coefficient of variation is 39.12%. So we always express the coefficient of variation as percentage. So this is how you can use calculator to solve this problem. Okay, so we got those three values: mean 31.29, standard deviation 12.24, and coefficient of variation 39.12. Now let's move on to next example. Here is the other example. The highway mileage, that is miles per gallon, for a sample of 10 different models of car company can be found below. Here we have that data. And we are asked to find the mode, that is the most repeating data value. If you look at this one carefully, you can see that this data, we have 45, 47, 33, 25, 40, 20, 43, 20, 22, and 48. So the smallest data value that is here is 20. This is the smallest. And the largest data value, if you look at all these values carefully, you'll see that the highest value is 48. So that is the largest data value. So this is largest data value. Now, if we try to answer this question in the first part, here you can see, find the mode. Mode is the most repeating data value. So you can see that 20 is repeating here. 20 repeats twice. That means the mode for the given data set is 20, because 20 repeats 2 times. So mode is 20. Next one, we are asked to find the mid-range. Mid-range is denoted by MR. And the formula to find the mid-range is the largest value plus the smallest value divided by 2. So here the largest value is 48, the smallest value is 20, and we divide that by 2. So that will be, you can see here 48 divided by 2 is 24, then plus 20 divided by 2 is a 10. So 24 plus 10 is 34. So the value of the mid-range is 34. And next one we want here is the range denoted by R. R is the difference between the largest value and smallest value. Largest value is 48 minus the smallest value is 20. 48 minus 20 is 28. So the range is 28. So that is the answer for the first part. We got the mode first, which is 20. We got the mid-range, that is 34. And here we got the range, that is 28. Okay, now in part B, we are asked to estimate the standard deviation using the, so here we are asked to use, estimate the standard deviation using the range rule of thumb. Range rule of thumb says standard deviation S, okay, standard deviation S is approximately equal to range divided by 4. So here from part A, we got range equal to 28 and we are dividing that by 4. So that is approximately 7. So according to the range rule of thumb, the standard deviation is 7. But remember one thing, the range rule of thumb is not the best estimation for the standard deviation. The standard deviation may be way different. The actual standard deviation may be way different from this 7. Now in part C, we are asked to use technology and find the standard deviation. So we are asked to check the standard deviation using the technology, and you'll find that it's different from 7. And also this is the sample data. You can see sample of 10 different models of car company. That means the standard deviation that you'll be looking here will be the sample standard deviation. So let's enter the data in the calculator and then find the sample standard deviation for part C. Okay, here's my TI-84 calculator. We go to stat and then under edit number 1, and under list 1, we enter the data like this. Once we enter the data, we go to stat and then we go to calculate and we select one variable stat. And after that, make sure your data is under L1. There is no frequency. We leave that blank and we hit calculate. So once you do that, you can see here, the standard deviation is 11.64. Sample standard deviation is 11.64 using our calculator. So from calculator, we got TI-84, from our TI-84 calculator, we got the sample standard deviation as 11.64, which is much different from the estimation using the range rule of thumb. Okay, that is the end of this example. Let's move on to the next one. Here is the other one. Look like this is a long question, but an easy one. Okay, for a 4-unit class like statistics, students should spend average of 12 hours studying for the class. So the average is 12 hours here. That is in general. But what is going on here is a survey was done on 20 students. Okay, when we do the survey on 20 students, and the distribution of the total study hours per week is bell-shaped or normal-shaped. The mean is 13 hours. So for that study, mean is 13 hours and standard deviation is 2.6 hours. We are asked to use the empirical rule to answer the following questions. So the first question is 68% of the students spend between how many hours on statistics each week? So if you think of the empirical rule, let me label this as part A, B, C first. So in part A, we want to find the number of hours spent by the students, okay, by the 68% of the students. And we know that 68% data is within one standard deviation. That means 68% is between one standard deviation of the mean. So it will be mean plus or minus one standard deviation. So here mean is 13 hours, then plus or minus the standard deviation is 2.6, which is equal to, so 13 minus 2.6, that will be 10.4. 10.42. Now 13 plus 2.6 is 15.6. 15.6 hours. So they spent between 10.4 and 15.6 hours. So that is the meaning of that, because 68% is about one standard deviation from the mean. Okay, now let's go to B. In part B, we're looking for 95%. And we know that 95% is between two standard deviation, according to the empirical rule. So it will be mean plus or minus 2 times the standard deviation, which is 13 plus or minus 2 times 2.6. And here, 13 minus 2 times 2.6 is 7.2. So it's from 7.2 up to 13 plus 2 times 2.6, that will be 18.2. 18.2 hours. So 95% student spend between 7.2 up to 18.2 hours every week on their study. Okay, now the third one, C. We are looking for 99.7%. And we know that according to the empirical rule, 99.7% is between 3 standard deviation about the mean. So it will be X bar mean plus or minus 3 standard deviation. Our mean is 13, then plus or minus 3 times 2.6. And here 13 minus 3 times 2.6, that is 5.2. So 5.2 up to 13 plus 3 times 2.6, that will be 20.8. So 95% of the students spend between 5.2 to 20.8 hours on statistics each week. So here what we did is we used the empirical rule to solve the problem. We use that empirical rule to solve the problem, because empirical rule says 68% of the data is within 1 standard deviation about the mean, 95% is within 2 standard deviation about the mean, and 99.7% is about 3 standard deviation from the mean. Example, please find the range sample standard deviation. Okay, we are looking for a range sample standard deviation and interquartile range of the following data. Use calculator to solve this problem. Okay, so here you can see on the first part, we need range, sample standard deviation, and IQR as mentioned here. And then a new number, 131, is added to the data set above. Please find the new range, sample standard deviation, and IQR of the new data set. And finally, what they said here is, which measure of spread is less affected by adding extreme observation like 131. So what we need to do is we need to enter the data first, enter this data, and then look for the 5 summary number. So let's do that first. So in our TI-84 calculator, we go to stat, under edit number 1, and under list 1, we enter the data. Once we enter the data, we go to stat, we go to calculate, one variable stat, that's what we select. We go all the way down here and press that calculate, and we'll be able to find the 5 numbers summary. So if we scroll down here, you can see that the minimum value is 37, Q1 is 47, median is 68, third quartile is 74, and maximum value is 94. So we get these 5 values, the 5 number summary from TI-84 calculator. So from our TI-84 calculator, we got these 5 numbers, and also the sample standard deviation. This one from TI-84 calculator is 19.3. 19.3. Range is the highest value minus the smallest value. So it will be 94 minus 37, which will be 57. Range will be 57. And the interquartile range is Q3 minus Q1. So the third quartile is 74 minus 47. And 74 minus 47 is a 27. So we got the range as 57, sample standard deviation 19.3, and interquartile range 27. Now what's going on here is in the same data, we are asked to add 131. We are adding one extreme value. Here is 94. We are adding a big number there, 131. And after we add that, we are using the calculator again to see the new range, new sample standard deviation, and new interquartile range. So let's get back to our calculator again. So we go to TI-84 calculator, we go to stat, under edit number 1. So in this list, all the way down here, we are adding that new number, which is 131. So after we add that new number, we go to stat again, and then we go to calculate, and we look at the first, one variable stat, which is the first one here. We go down here, select calculate. Then you can see that the sample standard deviation is 26.95. Sample standard deviation is 26.95. 26.95 is the sample standard deviation. Now, the 5-number summary. Let's find those 5-number summary. Minimum value is 37. In our 5-number summary, minimum value is 37. First quartile is 47, even after adding. And then median is 68. Third quartile is 92. And then the maximum value, the largest value we have added is 131. So these are the new 5-number summary from our calculator. Okay, we have the standard deviation, the sample standard deviation as 26.95. If we look at the new range is the new largest value minus the smallest value. So it is 131 minus 37. 131 minus 37 is 94. So your new range is 94. Now the next one we want is the interquartile range, IQR. IQR is the third quartile, which is 92, minus the first quartile, that is 47. And you can see 92 minus 47 is a 45. So our IQR is 45. So now if you try to compare here, you can see range. Let's look at the range. After adding the data, what happened? So first we have the values from this original data set. Once we enter the new value 131, let's see how the value changes. Range 57, now the new range becomes 94. So range has significantly increased. Sample standard deviation 19.3, and it is changed to 26.5. It has also increased significantly there. This is the standard deviation. And if you look at IQR, we have a 27 first, and now we have a 45. Although the largest value has increased a lot, third quartile has not changed that much. That's why we can see that the interquartile range is less affected by adding an extreme value. So which measure of spread is less affected by adding of the extreme value? We can say interquartile range. So let's write that down. For part C, interquartile range is less affected by the addition. Less affected by the addition of the extreme value. Okay, so that is the end of this example. We just entered a new data value to the original data set, and then we compared the different values. Example, on a recent quiz, the class mean was 75 You can see the class mean was 75, that is X bar, with the standard deviation of 4. So S is equal to 4. We are asked to calculate the z-score to 4 decimal places. So we have a formula for z-score. We have z equal to x minus x bar over s. Okay, the observed data value minus x bar over 4. So we are asked to calculate the z-score to 4 decimal places for a person who receive a score of 89. So you can see that they receive a score of 89. So that's their x value. So all we need to do is plug in those values here. So x is 89, x bar is 75 over 4. So 89 minus 75 divided by 4 will be 3.5. So the z-score is 3.5. That means 89 is 3.5 standard deviation above the mean. And also here we have a question, is this unusual? If you think of the empirical rule, we know that we have like 99.7% of the data, that's like almost 100% data is within 3 standard deviation. But this 89 is 3.5 standard deviation above mean. So it's much more compared to 3 standard deviation. Within 3 standard deviation, it should be 99.9 or almost everything there. So above that, it's definitely unusual. So we say, let's write this down. This score is unusual. Unusual because it is 3.5 standard deviation above the mean. 3.5 standard deviation above the mean. So since it is way above the mean, it is unusual. Normally, the data that is above 2 standard deviation, we consider unusual. And this is 3.5 standard deviation. So definitely, this is unusual. Example, the height of adult men in America are normally distributed with the mean of 69.1 inches and standard deviation 2.62 inches. So that's for the men. Okay, if we are looking at the height of adult American men, it's normally distributed with the mean of 69.1 inches and the standard deviation 2.62 inches. Similarly, in the question, what they said is the height of adult women in America are also normally distributed with the mean. Now you can see in this case, the mean is 64.6 inches and standard deviation 2.54 inches. What we're asked to do is if a man, okay, if a man 6 feet 3 inches tall, okay, 6 feet 3 inches tall. When we say 6 feet, so in 1 feet we have 12 inches. So 6 times 12 is 72 plus 3, that is 75 inches. So this is 75 inches. Let me use this color. Okay, 75 inches. So man, if you look at the general data for the man, mean is 69.1 and standard deviation is 2.62. Here, if a man whose height is 75 inches tall, what is the z-score? And if you remember the formula for z-score, z is x minus x bar over s. That's the formula. That's our formula. So for the first part, if we plug in the value, you can see our x is 75 minus the mean is 69.1 and we are dividing that by the standard deviation. For the men, standard deviation is 2.62. 2.62. And if we simplify this using calculator, this must be 2.2519. So that is the z-score for the man whose height is 75 inches. Now in part B, what we are asked to do is, in part B, if a woman whose height is 5 feet 11 inches tall, so if you look at the height here, 5 feet 11 inches tall, 5 feet 5 times 12 is 60, 60 plus 11 is 71. So this is 71 inches tall. What is the z-score? We have to find the z-score to 4 decimal places again. So now to find the z-score, we plug into the formula again. Same formula which is here, but in this case, in place of x, we have 71. So it is 71 minus the mean. Mean is 64.6. 64.6 over their standard deviation is 2.54. 2.54. So if we simplify this using calculator, 71 minus 64.6, divide the result by 2.54, we get 2.5197. Okay, 2.5197. So if you look at this z-score here, you can clearly see that the z-score for women is greater as compared to the men. So here is the question: who is relatively taller? 6 feet 3 inch tall man or 5 feet 11 inch tall American woman? So clearly 5 feet 11 inch American woman is taller compared to the man. So let me write that answer quickly here. So for part C, I can say since z-score, okay, since z-score for women is larger, they are taller. Compared to men. So that is the end of this example. Okay, we have next example on weighted mean or weighted average. Let's find out what is given. To compute a student's GPA, grade point average, for the term, students' grade for each course are weighted by the number of credit for the course. Suppose a student had the following grades. The grades are given here. What is the student's GPA for the term? And we have to give our answer to 2 decimal places. So here we have the value for each course, or the grade point for each course. So we are going to denote that by X. So for example, 3.9 is the X value. And also we have the credit value given, or the weight denoted by W. Now, if we look at this carefully, what we have is student have 3.9 grade value in a 5 credit class. Similarly, 2.0 in a 2 credit class, 2.0 in a 2 credit class, 2.5 in a 4 credit class, 2.5 in a 4 credit class, and then 2.9 in 6 credit class, 2.9 in 6 credit class. We are asked to find GPA, the grade point average. This is what we know. We know the grade point average is the weighted mean or weighted average given by the formula sum of X times W divided by sum of W. So in the table, we have X and W. So in next column, we need X times W. So let's find X multiplied to W. So first we have 3.9 multiplied to 5, which is 19.5. Next we have 2.0 multiplied to 2, that's a 4. Next we have 2.5 multiplied to 4, that's a 10. And finally we have 2.9 multiplied to 6, which is 17.4. Now let's add these numbers down here. We are going to add them so we can find the total. So total will be, if we add all the weight, 5 plus 2 plus 4 plus 6, that is equal to 17. And also if we multiply this product, X times W, 19.5 plus 4 plus 10 plus 17.4 is 50.9. Now we are all set to find the grade point average or GPA. So all we need to do is plug in the values here. Sum of X times W, sum of all this is 50.9, 50.9 over sum of W is here, which is 17. And finally, when we divide this 50.9 divided by 17 is 2.99. So that is the grade point average of this student for the term, 2.99. Remember, grade point average is the weighted mean calculated using this formula here. So that is the main formula that we need to remember. GPA or weighted average equal to sum of X times W divided by sum of W. Next example, the following, that means these questions here, refer to the following data set. Data set is given here. The first one is, what is the mean of the data set? So for part A, we need to find the mean. Part A is the mean, and we know that mean X bar for the sample is sum of X divided by N. That is, we need to add all the numbers, 71 plus 22 plus 23 plus 78 plus 60 plus 99 plus 68 plus 87 plus 70 plus 28 plus 99, which is 705 divided by N. N is the number of items here, or the number of data values. So we count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the mean will be 705 divided by 11, that is 64.1. 64.1 is the mean. Okay, the second part, part B, is what is the median of the data set? In order to find the median, we have to arrange the data. So let's arrange the data. Let me write this. Arrange data will be, you can see the smallest data value is 23, and we have two of them, 23, 23. Then we have a 28, and then 60, 68, hold on, that's 68, 68, 70, 71, 78, 87, then we have 299, 99 and 99. So we have 11 data points. So if we want to find the median, the middle value, we'll have 5 on each side. So we'll count 1, 2, 3, 4, 5, up to 68 on one side. Similarly, if you count 5 from the other side, 1, 2, 3, 4, 5. 5 and 5 on the side. And in the middle, you have a 70. So this value that is there in the middle, that's your median. So median is equal to 70. So for this data set, median is 70. Okay. I think over here, when I arrange the data, I have a 22 and 23. I wrote 23 and 23. That is 22 and 23. Let me correct that. So that is 22 and 23. Okay, let's move on to part C. In part C, we are asked for the mode of the data set. Mode is the most repeating data value. If you look at this arranged data, you can see that these values are not repeating all the way up to here. And when you go here, 99 repeats twice. Meaning of that is 99 is the mode. So we can write like this, 99 is repeated twice. 99 is repeated twice. So the mode is 99. So the mode is 99. It's because the most repeating data value is the mode. That's why mode is 99. Example, here is a frequency distribution table, sometimes referred or sometimes written in short like this, FDT, for a small data set. Find the following measure of central tendency. We are asked to find the mean, median, and mode. So we are looking for three measures of centers, mean, median, and mode. Okay, these three. And what we are asked to do is we are asked to show detailed work. Meaning of that is we are not using calculator. Instead, we are doing the actual math to find the mean, median, and mode. So this is the group data with the X values and frequency. And if you remember the formula for mean, let me write it down. So if we want to find the first thing, mean, denoted by X bar, is the sum of X times F divided by N. So that's the formula for the mean. So here we have X values as 42, 43, 44, 45, and 46. Frequencies are 18, 13, 16, 22, and 24. Now we need F times X because in the formula we have F times X here. So if we multiply 42 times 18, okay, if we multiply 42 and 18, that will be 756. Similarly, 43 times 13 is 559. 44 times 16 is 704. 45 times 22 is 990. And finally, 46 times 24 is 1104. Okay, once we have these values, let's try to add them together down here. Okay, let's find the total. So total number of observation will be 18 plus 13 plus 16 plus 22 plus 24. That will be equal to 93. And then sum of F times X, 756 plus 559 plus 704 plus 990 plus 1104 is 4113. 4113. Okay, so the mean will be, we plug in back to this formula here, which is equal to sum of F times X. Here is the sum, 4113. 4113 divided by N. N is the sum of frequencies, that is 93. And when we simplify this using calculator, 4113 over 93 is 44.2. 44.2. So the mean for the given data set is 44.2. So all we need to do is, in order to find the mean, we need to find F times X, add them together, and divide that by the total number of observation. Now, next one, we need to find the median. Okay, next one, we are looking for median. And when we say median, denoted by MED, It's the middle value in the observation. Middle value in the observation. Now, when we say middle value, first we need to know how many data values are here. That is, we have 93 data values. Let's also find the cumulative frequency at the site. Sometimes that will be helpful. So let's find the cumulative frequency. The first frequency is 18. The next one is 18 plus 13. That will be 31. 18 plus 13 plus 16. That will be 47. 18 plus 13 plus 16 plus 22, that's a 69. And then 18 plus 13 plus 16 plus 22 plus 24, that is a 93. That's a 93. Okay, we're looking for the middle value. There are 93 observations. And if you think of the middle value, that is the 47th value. That is equal to 47th value in the data set. 47th value in the data set. Meaning of that is you'll have, let me show you here, you'll have 46 data values here, 46, and this is the 47th. And this side, you'll again have 46 values. 46 values. So you can see you have 46 values, 46 values. If you add, that will be 96 values. And here in the middle, you have the 47th value. And that 47th value is the median. 47th value is the median. That's the meaning of that. If you remember in the previous example here, when you have 11 of them, we have 5 this side, 5 this side. So since we have 5 here, the 6th one is the median. Same thing here. When you have 93, we'll have 46 values this side, 46 values this side. The middle value, which is the 47th value, will be the median. And if you look here, the 47th value, as you can see, there is a 47th value. And the 47th value, this is the 47th item. The 47th value is 44. So if you think of this carefully, when we say 42 has a frequency of 18, that means we have 42, 42, 42, 42, 42, 18 times. And then we have 43, 43, 43, 13 times. Similarly, we have 44, 44, 44, 16 times. 45, 45, 45, 22 times. 46, 46, 46, 24 times. So on 47th position, as suggested by the cumulative frequency here, at 47th position, we have 44. So this is equal to 44. So we can say median is equal to 44. Okay, median is 44. So that is the second thing we want. Now let's go to the last one. So the third one we want is the mode. And if you think of mode, mode is the must repeating data value. Must repeating data value. So if you look at the table, 42 repeats 18 times, 43 repeats 13 times, 44 repeats 16 times, 45 repeats 22 times, and 46 repeats 24 times. So you can see 46 has a highest frequency, 24. So 46 is the mode. So you can see 46 repeats the most. So this implies mode is 46. So that's how we can solve this type of problem manually. We got the mean as 44.2. We got the median 44. And then we got the mode here, which is 46. Next problem. In a city with 3 high schools, you can see the name of the high schools here, Glenwood, Central, and Lincoln. All the 9th grader took a standardized test with these test results. Here's the test result. Mean test score of Glenwood High School, 78, Central High School, 91, and Lincoln, 72. And The number of ninth grader who got that score, you can see the number of ninth grader, okay, who got 78 is 254, 91, 332, and then 72, 177. The city's PR manager, who never took statistics, claimed that the mean score of all ninth grader in the city was average of 78, 91, and 72. So they were saying these numbers, which will be 80.3. So they're just adding this and divided by 3, and they're getting 80.3. Of course, that's not the way we find the mean. So of course, that is incorrect. And now you know how to find the mean. So what is the mean score of all ninth grader in the city? So let's do that. So this is the group data. And you know that the mean of the group data, let me write here, mean of the group data is given by the formula sum of f times x divided by n. That's our formula. So here, the x values are the test score. Okay, x values are the test scores, which are 78, 91, and 72. Frequencies are given as 254, 332, and 177. Now, to find the mean, we need f times x. So we multiply this. 78 times 254 is 19,812. 91 times 332 is 29,302. And then 72 times 177 is 12,744. Okay, let's also find the total quickly. So the total will be, if we add all these frequencies, it will be 753. And if we add all these numbers here, f times x, that will be 61,858. Okay, so once we have these values, we can plug in here to get that mean. So if we plug in, that will be equal to 61,000 here, 61,858 divided by our n is 753. That's the total number of students. So this implies our mean, the actual mean will be 16,858 divided by 753, that will be 82.1. So the true mean is not 80.3, instead it is 82.1. So we use the formula to find the mean, and we got the exact mean as 82.1. Time for next example. Every year, the students at a school are given a musical aptitude test that rates them from 0 through 5. So 0 means no musical aptitude and 5 means high musical aptitude. This year's results are tabulated below. Here we have the aptitude score and the number of students or frequency. We are asked to find the mean, median, and mode score, and we are asked to show the work in detail. That means we are doing the actual calculation to find the values. We are not using calculator. So first, let's begin with the calculation of mean. And you know that to find the mean, we have the formula. Let me write it down here. Mean for sample data denoted by x bar is the sum of x times f, or you can also write f times x divided by n. So here we have the data value. Let me make a quick table here. Okay, we have the data value x. These are scores from 0 through 5. 0, 1, 2, 3, 4, and 5. We have frequencies 4, 3, 4, 2, 2, and 0. To find the mean, we need f multiplied to x or x multiplied to f. So let's do that multiplication. So first one we have 0 multiplied to 4, that is a 0. And then 1 times 3, that's a 3. 2 times 4, 8. 3 times 2, 6. 4 times 2, 8. And then 5 times 0 is a 0. Okay, those are the products. Now, let's add some of them. Okay, so let's find the total values. So total will be, if we add here, in order to find the total number of observation, aptitude score 0 is 4, 1 is 3, 2 is 4, 3 is 2, 4 is 2, 5, none. So if we add all these, the total number of students will be 15. Now, the product is we add these numbers. So if we add all these, that's 25. So to answer the first part, mean, we can say mean x bar is the sum of x times f over n, which will be equal to the sum of x and f is a 25 divided by n. N is the total number here, which is 15. So 25 over 15 is 1.7. So the mean is 1.7. Now the next one we need to find here is the median. So median, okay, let me write here. Median, denoted by MED, is the middle value in the observation. So the total number of observation is 15. So when we have 15 observations, we can have 7 observation on one side, and then we have the 8th observation, and then remaining 7 there, like that. So 7, 7, 14, 1 in the middle, 15. So the value in the middle will be the median. So meaning of that is the 8th value will be the median. So here we have 4 zeros, so 4 of them, 3, 1, so 4 plus 3, 7. So the 8th item will be this one, 2. 8th item will be 2. Okay, so the median will be 2. Median is the 8th item or 8th data value, you can say. 8th data value, which is equal to the 8th data value here is 2. Make sure you know this, how I'm getting 2. We have 4 zeros like this. Zeros, we have 4 of them. 0, 0, 0, 0, like that. 4 zeros. Then we have 3 ones. 1, 1, 1. And then we have 4 twos. 2, 2, 2, 2. That's how the data continues after that. Okay. Then we have 3 twos. I mean, 2 of the 3s, 2 of the 4, and no 5. That's the meaning. And we know that the median is the 8th item. So now technically we count here 1, 2, 3, 4, 5, 6, 7, 8. So you can see that in 8th position, we have 2. So that value, which is there in the 8th position, okay, that is the median. You have 7 data points on this side. Count 1, 2, 3, 4, 5, 6, 7. You will have remaining 7 on this side. You will have remaining 7 on this side. So the value that is exactly in the middle, that is the median. So that's why median is the 8th data value, which is equal to 2. Okay, next thing we want to find in this one is the mode. Okay, mode. Let's find out what is mode. Mode, you know that mode is must repeating data value. Must repeating data value is mode. And you can see that 0 repeats 4 times, 1 repeats 3 times, 2 repeats 4 times, 3 repeats 2 times, 4 repeats 2 times, and 5 repeats 0 times. That means here you can see 0 repeats 4 times. Okay, so 0 repeats the most, and also 2 repeats the most. That means there are 2 modes. The modes are 0 and 2. 0 and 2. So meaning of that is this data is bimodal data because the most frequently occurring data values are 0 and 2. Both of them occur 4 times. Other values occur less than 4 times. So this is how we can solve problem like this one. So here we got mean 1.7, median 2, and mode 0 and 2. So we completely answered this question. Example, calculate the mean, median, and mode. Okay, mean, median, and mode for 2 sets of data given here. Please show your work to 1 decimal place if necessary. So if you're getting a decimal value, give your answer to 1 decimal place. So work in detail. And here the data given is the individual series or ungrouped data. So let's solve the first part and we'll go to the second. So for the first part, to find the mean, let's start with the mean. So first thing we want is mean, denoted by x bar, is the sum of x divided by n. That is, we have to add all these data values and then divide by n. So if we add all these numbers, okay, if we add all these numbers, we'll get 777. 777 divided by the total number of observations. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is 777 divided by 11, which is equal to 70.6. So that is the mean for this data set. Next thing, we want median. So in order to find the median, we have to arrange the data. So let's do that. To find median, we arrange data. We arrange data. So here in this data set, you can see the smallest data value is 22. So we start there, 22. Next one is 30, then 48. As you can see, 63, 71. Next we have 73. And then we have 89. Then we have 93. Then we have 94. Again, 94. And finally, we have 100. And we know that there are 11 data sets. So when you divide it into 2 parts, you'll have 5 on each side. So we'll have 1, 2, 3, 4, 1, 2, 3, 4, 5 on one side, like that. Other 5 on the other side, 1, 2, 3, 4, 5 on the other side. And you'll see one value in the middle, that is the median. So that value is the median. So median is equal to 73. Okay, median is 73. Next, we are asked to find the mode. And you know that mode is the most repeating data value. Mode is most repeating data value. Okay, mode is most repeating data value. It is easy to check the repetition from the well-arranged data. So as you scan this one, you can see that the 94 repeat twice. That means your mode is 94. Mode is equal to 94. So for the first set of data that is given here, we got mean 70.6, median 73, and mode 94. And we are going to do the same thing with the second data set again. So let's go to the second data set and then do the same thing. So for the second data set, Mean, same formula again. Mean denoted by x bar is the sum of x divided by n. So if you add all these numbers, 71 plus 92 plus 85 plus 21 plus 41 plus 49 plus 100 plus 54 plus 49 plus 59, if you add all those numbers, it is 621. And we are dividing by the total number of observations. You can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. So that is equal to 62.1. So the mean for this data set is 62.1. Next one, we want to find the median. We got the mean. So next one, we want the median. So in order to find the median, we need to arrange the data. So let's arrange the data. To find median, we arrange data. You can arrange in ascending order or descending order. I'm going to arrange in ascending order. So if you look at this data set, you can see that the smallest data value is 21. So we are going to start there. So you have a 21, then you have 41, 49, again 49, 54, then you have a 59, you have 71, then you have 85, 92, and 100. So we arrange the data in ascending order. We have 10 observations. So if we divide into two parts, you'll have 5 on each side. So if you count 1, 2, 3, 4, 5 on this side, and the other 5 on this side, 1, 2, 3, 4, 5. That means median lies here in the middle. So median lies between, you can see 54 and 59. So if median lies between two numbers, we add these two numbers and divide by 2. So it will be 54 plus 59 divided by 2. And 54 plus 59 divided by 2 will be 56.5. So the median for this data set will be 56.5. Finally, let's look at the last one, that is the mode. Okay. One more time, mode is the must repeating data value. Okay, mode is must repeating data value. That's the mode. So if you look at the arranged data, you can see the repetition. Here 49 repeats twice. And let's see, nothing else repeats. So 49 repeats twice, meaning of that is mode is equal to 49. So for the second data set, we got all the values that we are supposed to calculate. So here we got mean 62.1, median 56.5, and mode 49. So that's how we can solve problem like this one. Next example, 20 randomly selected students were asked the number of movies they watched the previous week. The results are as follows. No movies, 0, 3 students. 1 movie, 2 students. 2 movies, 4 students. 3 movies, 2 students. 4 movies, 2 students. 5 movies, 6 students. And 6 movies, 1 student. Round all your answer to 4 decimal places. So we are trying to round the answer to 4 decimal places here where possible. And we are asked to use calculator to solve this problem. So in the first part here, we are asked to find the mean, median, and sample standard deviation. Okay, mean, median, sample standard deviation, first quartile, and third quartile. 1, 2, 3, 4, 5 things. So what we are going to do is, first we are going to enter the data in our TI-84 calculator and try to answer these questions. So let's move to TI-84 calculator here. Okay, here is my TI-84 calculator. What we do is, we go to stat, and under edit, we go to number 1. Under list 1, we enter the number of movies 0, 1, 2, 3, 4, 5, 6. And under list 2, we enter the frequency or number of students 3, 2, 4, 2, 2, 6, and 1. So once we enter the data in this calculator like this, number of movies under L1 and frequency under L2, we go to stat and then we go to calculate. We select one variable stats, and then your list or the score, in this case, the number of movies is under list 1, which is good. Frequency is under list 2, so we need list 2 here. So we press second and then number 2 to bring that list 2 there. Then we go and select this calculate and hit enter. So once you do that, you'll see all the information that you need. For example, the mean that we are looking for. So mean is 3. Okay, mean, which is denoted by X bar here, you can see that's a 3. Median was the second thing. So if you scroll a little down here, you'll see median is also 3. Okay, mean and median are equal. Sample standard deviation is this one. Sample standard deviation. So if we go to 4 decimal places, let me change this one. It's fixed to 2 decimal places, but in this example, we want 4. So let me go here and change to 4 decimal places. Okay, let me do that. 4. Okay, there we go. 4 selected. Let me go back and bring that screen back again. Stat, calculate, one variable stat. Everything is set there. So if we hit calculate, then we see that. So standard deviation that we were looking, it is 1.9735. 9735. First quartile or Q1 is 1.5. And then the third quartile is Q3. You can see it is 5. So we are just asked to find those 5 things. So from our TI-84 calculator, we got mean denoted by X bar equal to 3. Median, you can write MED equal to 3. Sample standard deviation S equal to 1.9735. First quartile, that is Q1, is equal to 1.5. And the third quartile, that is Q3, is equal to 5. So that is for the first part, A here. Now let's go to B. In part B, the question says, what percent of the respondent watched at least 6 movies previous week? So you need to know the meaning of at least 6. When we say at least 6 means, okay, at least 6 movies, meaning of that is 6 or more. 6 or more, that is the meaning. So you can see 6 movies. Here we have 6 movies. One student watched that. One student watched 6 movies. And more than 6 we don't have. That means what percent? We need the percentage for that. So for part B, we saw that one student out of all these students, if we add 3 plus 2 plus 4 plus 2 plus 2 plus 6 plus 1, so the number of students in the survey is 20. So one student out of 20, okay, one student out of 20 watched 6 or more movies. At least 6 means 6 or more movies. But we want the answer as percent. That means if you want to change the fraction to percent, we multiply by 100. So if you multiply by 100, that will be a percentage. So you can see 100 multiplied to 1, that is 100 divided by 20%. And 100 divided by 20 is 5%. So that means 5% student, okay, watch at least 6 movies previous week, 6 or more movies previous week. So that is the answer for part B. Now let's look at part C. What is asked in part C? So in part C, they said 56% of all respondents watch fewer than how many movies? When we say fewer than how many movies, that means less than how many? Fewer than means less than how many? Less than how many? Let me put that X. Less than how many? So here we said 56% of all respondent. When we say 56% of all respondents, meaning of that is 0.56 multiplied to 20. And if we do that, 0.56 multiplied to 20, that will be 11.2. Okay, 56% means 11.2. You can see 3 students watch 0 movies. Now, if we go here, if we do these two, 3 plus 2, that will be 5. 5 students watch fewer than 2 movies, less than 2 movies, that is 1 and 0. Now, if we go here, see, we are going up to 11, okay? We are going up to 11. So if we go here, 3 plus 2 plus 4, 3 plus 2 is 5, 5 plus 4 is 9. We want to go up to 11. So 9 students watch less than 3 movies. Okay, that's 9. 9 plus 2, this becomes 11. When we go to 11, then you can see that 11 students watch less than 4 movies. Okay, 11 students watch less than 4 movies. But here we have 11.2, 56% is 11.2. So which is approximately 11 students. Okay, 11 students. So 11 students will be here. 3 plus 2, 5 plus 4, 9 plus 2, 11. So this much students will be 11. And you can see that these students watch less than, this is 11 by the way. This is 11. Okay, 11, or you can say this is 56%. 11 or 56%. So 11 students or 56% students, you can see they watch less than how many movies? As you can see here, they watch no movies, 1 movie, 2 movies, or 3 movies. That means they watch less than 4 movies. So meaning of that is 56% of all respondents watch less than how many movies? As you can see here, 4 movies. So that is, they watched less than 4 movies. Okay, so they watched less than 4 movies. So that's how you need to answer this question. We have a similar problem in next example. Let's also solve that. So here is that example. 66 randomly selected students were asked the number of pair of shoes they have. So here you can see 4 pair of shoes, 4 students, 5 pair of shoes with 5 students, 6 pair of shoes with 5 students, 7 pair of shoes with 5 students, 8 pair of shoes with 8 students, 9 pair of shoes with 7 students, 10 pairs with 8 students, 11 pairs with 5 students, 12 pair with 6 students, 13 pairs with 6 students, and 14 pairs with 8 students. We have the data here. We are asked to round all answer to 4 decimal places where possible, and we are asked to find the mean, median, sample standard deviation, first quartile, and third quartile. Just like in the previous problem, we are asked to find mean, median, sample standard deviation, first quartile, and third quartile. We are also going to use calculator and find this value. So as you can see, the first one we want is the mean or X bar. Second is the median. Okay. Third one is the sample standard deviation. Fourth is the first quartile. And the fifth one is the third quartile. So let's bring our TI-84 calculator. Here's my TI-84 calculator. First, we are going to enter the data. We go to stat, under edit, number 1. And under list 1, we enter the number of pair of shoes. And under list 2, we enter the frequency. So once we do that, we go to stat and then calculate, and we select number 1, which is 1 variable stats. And make sure we have list as L1, frequency as L2. Then we select calculate and hit enter. So we get all the values that we want. So here you can see our mean, okay, the first part is the mean, and you can see our mean is 9.4030. Mean is 9.4030. So that's mean. Now median will be a little bit down here. You can see median is 9. Okay, median is 9. Sample standard deviation denoted by S is here, which is 3.0652. 3.0652 is the sample standard deviation. First quartile is this one, Q1, which is 7. And third quartile should be a little bit down. So let's go a little down here. You can see third quartile is 12. So we can use calculator to find these values. Okay, these are the 5 values that we get from the calculator. Mean 9.4030, median 9, sample standard deviation 3.0652, first quartile 7, third quartile 12. So wherever we got decimal, we write up to 4 decimal places. So that's for part A. Now let's look at part B. In part B, the question is, what percent of the respondent have at least 10 pair of shoes? So when we say at least, one more time, at least means at least 10 means 10 or more. That is the meaning. 10 or more. So if you look at the data that is given there, okay, if you look at the data that is given there, you can easily find how many have at least 10 pair of shoes. So you can see 10. So they have 10 pair, at least means 10 or more. Okay, 8 of them have 10. Then after that, we have 5 of them more than 10. Again, 6 of them more than 10, more than 10, more than 10. So all of these, they have more than 10 pair of shoes. So you can see all these students here, they have 10 or more pair of shoes. So if we add these numbers, you can see 8 plus 5 plus 6 plus 6 plus 8, that total will be 33. That means 33 students, okay, or 33 of them have at least 10 pair of shoes, 10 or more. So that is 33 out of 67 students, right? Because the total number is 67. So almost half. So out of 67, 33. Now this is a fraction, but we want the answer as percent. So we multiply by 100. And if we multiply by 100, that will be in percentage. So this will be equal to 33 times 100, 3300 divided by 67. Your result will be in percentage. So this simplifies to 49.2537%. So 49.2537% of the students have at least 10 pair of shoes. That is 10 or more pair of shoes. That is the meaning of that. Now let's move on to the next one. So in next one, the question says 14% of all respondents have fewer than, when you say fewer than, meaning of that is less than how many pairs? Less than X. And we need to find that X. And here we are talking about 14%. So 14% of all respondent. You can see all respondent means 67, which will be equal to 14%, 0.14 times 67. So we can multiply this. 0.14 times 67 will be 9.38. Here we are looking for the number. So this is approximately 9 students. Okay, this is like approximately 9 students. So 9 students have fewer than how many pair of shoes? You can see 4 students have 4 pairs. That means these 4 students, try to understand here, 4 students have less than 5 pairs. That is the meaning. Now 5 plus 4, this becomes 9. Okay, the 9 that we are looking for. 5 plus 4, 9. So this is 9. You can see that these 9 students, they have either 4 pairs or 5 pairs. That means that is less than 6. Okay, so less than 6. So 9 students will have less than 6 pair of shoes. So this implies they have less than 6 pairs. So 14% of the students have less than 6 pair of shoes. So that is the end of this example and also the end of the entire very long video. Thank you so much for watching. I hope you find all these very, very helpful.